This is the business black book, where billion-dollar empires are built and collapse. What if a two-digit shortcut, written by a programmer in 1958, almost brought down the entire global financial system 42 years later? No bombs, no war, no natural disaster, just two missing digits. And the world came terrifyingly close to a collapse it never saw coming. This is the business black book, where billion-dollar empires are built and collapse. Let us talk about something that most people today either laugh at or completely misunderstand. The Y2K bug. Some people call it the greatest panic in modern history. Others call it the greatest tech fix in modern history. And the truth is somewhere in the middle. But to understand what really happened, we need to go back, far back, to the very beginning of how computers were built, and more importantly, how they were taught to think about time. The year is 1958. Computers are not personal devices sitting on your desk. They are enormous machines, filling entire rooms, costing more than most people earn in a lifetime. These machines were born out of World War II, built for calculations, for military logistics, for scientific research. And one of the most brilliant minds working with these machines was an IBM employee named Bob Bemer, a computer scientist who was thinking decades ahead of his time. Bemer noticed something, a small design choice that seemed harmless in 1958, but had the potential to become catastrophic decades later. You see, memory on these early computers was extraordinarily expensive. Every single byte of storage had a cost attached to it. And so engineers did what any rational person would do when resources are limited. They cut what seemed unnecessary. And what seemed unnecessary was the first two digits of a year. Think about it from their perspective. If you were writing a date in 1958, why would you write 1958 in full? Everyone knows it is the 1900s. Just write 58. Save the memory. Save the cost. Move on. And so computers were programmed to only recognize the last two digits of any given year. 1972 became 72. 1985 became 85. Clean, efficient, logical. Except, nobody seriously asked the question, what happens in the year 2000? Because 2000, in a two-digit system, becomes 00. And a computer seeing 00 does not think, ah yes, the year 2000. It thinks, is this the year 1900? Or the year 2000? The machine has no way to know. And depending on how it was programmed, it could read 00 as the furthest point backward in time and start calculating everything from there. Now here is where it stops being a computer science problem and starts being an economic and social catastrophe. Let us take the most obvious example. Banks. Banks do not just store your money in a vault and leave it alone. Their computer systems are constantly calculating interest rates, compounding returns, loan schedules, transaction histories. All of these calculations are built around time. The date is not just a label in a banking system. It is an active variable inside thousands of financial equations running simultaneously. So imagine what happens when the bank's computer wakes up on January 1st, 2000, reads the date as 00, and concludes that the year is 1900. Now it is trying to calculate the interest on your savings account going all the way back from 1900 to the year 2000. 100 years of compound interest suddenly appearing in someone's account. This actually happened. In Germany, on January 1st, 2000, one man briefly found $6 million in his bank account. His transaction history showed a date of December 30th, 1899. The bank system had malfunctioned and compounded interest for an entire century. That was one bank that had not updated its software in time. Now picture that happening at every bank, in every country, simultaneously. People would see numbers in their accounts that made no sense. Some would see fortunes. Some would see nothing. Some would see overdrafts that did not exist. People would panic. They would run to withdraw cash. Banks would empty within hours. Stock markets would collapse as panic selling began. And just like the crash of 1929, but driven by bugs instead of bad loans. The entire financial architecture of the modern world could start to unravel. And it was not just banks. In Japan, nuclear energy plants had alarms start triggering just minutes after midnight on January 1, 2000. Now think about what that means when applied to something far more dangerous. Early warning systems for nuclear missiles also rely on computers. They also use timestamps. If a defense system reads the year as 1900 and flags an incoming missile as originating from an impossible timeline, what does it do? Does it launch a counterstrike based on corrupted data? The fear was not irrational. It was rooted in a very real and very logical chain of consequences. So how did we arrive at this moment, knowing the problem existed since 1958, and doing almost nothing about it for 4 decades? The answer is a very human one: procrastination, assumption, and the quiet arrogance of believing that future technology will solve today's problem. In 1958, the year 2000 was 42 years away. Nobody building computers in that era expected those same machines to still be running in the year 2000. The assumption was simple. By then, everything will have been upgraded. New technology will have replaced these old systems. The problem will take care of itself. Except it did not. Companies across the world kept using old systems because old systems still worked. There was no economic incentive to upgrade a machine that was doing its job perfectly well. If the 30-year-old computer is running the payroll without any issues, why spend millions replacing it? This logic, repeated across thousands of companies and government departments globally, meant that by the time the 1990s arrived, the world was sitting on a ticking time bomb made of outdated code. And here is where the third dimension of the Y2K story enters: the information dimension. The 1990s were a unique and strange moment in human communication. The internet was new. Personal computers were becoming household items. But most people still fundamentally trusted traditional media. Television, newspapers. What the anchor said on the evening news was what you believed. And the media, recognizing the fear and confusion already present around computers, went to work. Sensationalism sold. Fear generated ratings. And so alongside the legitimate warnings from engineers and government bodies, came a wave of exaggerated headlines. Airplanes would fall out of the sky. Power grids would collapse. Prison gates would swing open. Famine would follow. The apocalypse was arriving on a schedule, and the schedule was January 1st, 2000. People emptied shelves. They bought survival kits. They stockpiled food and water. Weapons sales increased. A quiet but very real hysteria crept into everyday society. Now here is the misconception that most people carry today. They believe Y2K was a hoax. That nothing was ever going to happen. That people panicked over nothing. That is not accurate. Y2K was a real technical problem. The bug existed. The risk was genuine. What was exaggerated was the scale of the catastrophe that would have resulted if nothing had been done. The truth is, something was done. Enormous amounts of work and money went into fixing it. The United States alone spent roughly $100 billion on what was officially called the Y2K repair bill. Governments around the world mobilized their technical departments. Thousands of programmers spent years going through millions of lines of old code, line by line, updating date formats, testing systems, building contingencies. There is a film from that era called Office Space, released in 1999, which accidentally serves as a perfect cultural document of this moment. A character explains his entire job as simply sitting in a cubicle, going through thousands of lines of bank software code, updating the date format for the year 2000 switch. That was a real job. Hundreds of thousands of people had that job in the late 1990s. And there is an interesting comparison that reveals how complicated the truth of Y2K really is. The United States spent massively on Y2K remediation. Italy spent very little. And both countries experienced roughly the same level of visible disruption. Some people use this to argue that Y2K was overblown. But this argument ignores a critical variable. Italy's government departments and private businesses still conducted testing and preparation. Even if their headline spending was lower, the disruption was minimal because the preparation happened, not because the problem did not exist. Here is what a financially and technologically aware person should take away from this story. Systems are built by humans, and humans optimize for the present, not the future. The two-digit year shortcut made complete sense in 1958. Nobody was being reckless. They were being practical. But practical decisions made today can carry hidden costs that only surface decades later. This is as true for business decisions, financial structures, and government policy as it is for software design. The second lesson is about how information travels through society and shapes behavior. Y2K showed the world what happens when legitimate technical risk collides with media sensationalism and a public that does not fully understand the technology it depends on. The fear was real. The preparation was real. But the apocalypse narrative was manufactured, and it caused real economic and social damage of its own kind. And finally, Y2K produced one genuinely positive outcome that rarely gets mentioned. The crisis, or rather the threat of crisis, forced a global upgrade of outdated computing infrastructure that would have taken decades longer under normal circumstances. Systems that should have been modernized in the 1980s were finally brought up to date. The fear, however exaggerated, created the pressure required to do what should have been done all along. 2 digits. That is all it was. 2 missing digits in a line of code written before most of the world's current population was born. And those 2 digits created a chain of consequences, spanning 4 decades, costing $100 billion, and reshaping how governments, businesses, and individuals think about technology, risk, and the price of procrastination. The next time someone tells you that a small technical detail does not matter, remember Y2K. Because in the world of systems, there is no such thing as a small detail. And with that, the Black Book closes. Subscribe, and we will open the next page soon.